All right, this is for 1 day 23, example 2. So in this problem, we're looking to find the absolute maximum and minimum values for this function on a closed triangular plate in the first quadrant, which you can see is this region here. This is x equals 0 here, and then y equals 9 minus x is this line, and this line here, of course, is y equals 0. Okay, so that's the bounded region. All right, and so to find the absolute max and absolute min, let's first check the interior points. Okay, so to check the interior points, let's look at the partials. So f of x is going to give me 2 minus 2x, setting that equal to 0. We get that x is equal to 1. Looking at f of y, that partial, that's going to give us 2 minus 2y equals 0. So it looks like y is equal to 1. Okay. So if we plug in these values, so f of 1, 1, we get 2 plus 2 plus 2 minus 1 minus 1, so 4. Okay. All right, so that's the value of the interior points, the value of the critical point. So now let's check the boundary. Okay. All right, so along the line, let's see, how about CA here? So that's this bottom boundary. If we check there, we have that y is equal to 0. So f of x, y, is going to be 2 plus 2x minus x squared on the interval from 0 to x is less than or equal to 9. Again, that's going to this boundary here. Okay. So there is our conditions, and so at x equals 0, the left-hand point, we have f of x, y equals 2. This is at the point C. And then at x equals 9, we have f of x, y equals negative 61, and that's at A. Okay, and then in between 0 less than x less than or equal to 9, f of x is 2 minus 2x equals 0, so x equals 1. So f of 1 comma 0 is going to give us 3. Okay. All right, let's consider the other two segments. Okay, so following a similar manner, AB, we're going to have AB is this line here. It's a diagonal line here. Okay, so in that situation, we have y is equal to excuse me, negative x plus 9. And so if we plug that into, it's going to imply that f of x comma y is going to equal 2 plus 2x plus 2 times 9 minus x squared minus 9 minus x squared. Okay, just replacing y in its relationship to x along this boundary. Okay, in doing that, we're going to have for AB the endpoint, so f of 9 comma 0, and that's going to give me, if I plug in 9 here for x, that gives me 81. It's 81, sorry, 61, negative 61. That's at A. We found that from up above. And then f of 0 comma 1 is equal to negative 61. This is at B. It shouldn't be too surprising given the symmetry of the problem that these two are the same. And then finally, when f of x is equal to 2 minus 2 minus 2x plus 2 times 9 minus x, which equals 18 minus 4x, which equals 0, so x is equal to 9 halves. If we plug that in, we get f of 9 halves, and, 9 halves. That equals a negative 41 over 2. Okay. Alright, so that covers all those values, and now finally, let's explore this a little bit more. So AB, so we have the last segment there, which is BC. This is a vertical strip on our problem. So we have BC, which is a vertical strip. So here, this is along the vertical line, x equals 0. So this is going to be between y going between 0 and 9. And so f of xy equals 2 plus 2y minus y squared. Okay, so at y equals 0, f of xy equals 2. That's at C, and then at y equals 9, f of xy is equal to negative 61. Again, it's B, so that's no surprise. In between, fy is equal to 2 minus 2 equals 0. So y is equal to 1. So f of 0 comma 1 is equal to 3. Okay. So let's kind of come over here and let's list our candidates. And if we do that, we have A is equal to f of xy is equal to negative 61. This is for x equals 9, y equals 0. B is x equals 0, y equals 9. Similar, and this is, so these two are essentially the same, and these will be the minimum values. Okay, let's look at C. So here x equals y equals 0, and f of xy is equal to 2. Let's see, and 9 halves and 9 halves. We get negative 41 over 2. At 0, 1, we get 3. At 1, 0, we got 3. And at 1, 1, we get 4. So here's the max, and there's the min. Okay. All right, so we've found all the maximums and minimums for this function on this region. Hope that was helpful. See you in the next video.